In this video, we're going to look at UCS constraint sets inside of Autodesk Inventor's assembly environment. And now, in order to utilize this particular type of constraint set, you need to have custom-defined UCSs inside of your part files. Now, the way that you set these up inside of your part files is pretty easy to do, but what you need to consider when you're using a constraint set is the orientation that they sit in. When you get to the assembly level and you want to put together two very complex pieces, such as these two exhaust manifolds, maybe I need to have them hooked together end to end with a specified rotation already set in place. You can tell on this particular one here on the left, I have a certain rotation set up on this UCS triad that was created inside the part level. On the other component, I also have another UCS set up, but without its rotation. Inside the assembly, when you choose the constrain command, the last option here is called constraint set. This will allow you to marry up the two UCSs so that they overlap together to the X, Y, and Z planes exactly. So the fact that one is turned and one is not essentially has put in my rotation value for me ahead of time. So here with UCS constraint set, I'll choose this constraint set here and this other UCS to hook together. You can see they automatically come together. There's no other constraints needed. If I choose OK here, this is a fully locked in place component. Instead of having to do multiple face mates or flushes or angle constraints to lock out rotations or joints, I've done that very quickly with this one command. Now, speaking from a very high level point of view of why these are useful, whenever you have something that's really complex geometry having to mate up to other really complex geometry, this is a great idea so you don't have to fight with your assembly constraints or joints over and over again once you get to this stage of the design. They are very handy for complex curvature pieces, for things that don't have a necessarily defined edge, and also so you don't have to go through and dig into creating different work features or work planes to help you create the eventual constraint that you would need. Speaking from another more advanced technique, if you're doing things such as eye assemblies or eye logic automation, it's a lot easier to turn off a constraint set rather than having to turn off multiple work features or multiple constraints or joints that would really accomplish the same thing. So it's basically less coding. It's more seamless, if you will. So let's take a look at another one. I have UCS Constraints 2 open as well. And here you can definitely tell I have a lot of complex curvature going on. What's unique about this particular design is every part is designed in reference to the exact center of the engine block. So when I need to put these parts together, I can basically put all my engine part centers together. Now, you could do this with origin features if you shared the same origin over and over again. You can also define a UCS like I've done here and put the two UCSs together. Now, if you were going to try to mate this windshield into that car body, with traditional constraints, it might be rather difficult. So here I'll use my constraint set command again, choose this constraint set to hook onto this other constraint set. I'll apply that and close the dialog. So there, with one command, I have my windshield put into the car body exactly how I want it to be. In conclusion, if you use the UCS coordinate systems inside your part mode and your assemblies correctly, you have some really high-end capability to utilize Autodesk Inventor for stability. However, there's a lot of setup involved in creating UCSs inside of your part mode and having that forethought down the line. So generally, this is something you run into during high-end configuration projects or high-end designs where you have a lot of curvature like you see here.